So now in today's lecture we are going to discuss the cube problem, right? You may write it is the cube problems, right? So the few standard problems related to the cube, to find the flux linked with the cube we have to find. For example, the first example I am taking, suppose if this is the cube, right, and this is the cube of the side A, suppose, and a charge Q, right, capital Q is placed at the center. The charge capital Q is placed at center, right, at center. You have to find the electric flux linked with, right, linked with cube and one face of cube, right? This is the question. Is it clear or not? Right, copy this. So what is the question, please tell? If one charge capital Q is placed at the center, so what is the flux linked with this cube? You tell. According to Gauss's law, what is the Gauss's law? Gauss's law is nothing but the net outward flux linked with any closed surface is equal to charge enclosed divided by epsilon naught. So if you consider this is the closed surface, so the flux linked with this cube is what? Listen, the flux from if you consider this is the cube, right, this is the cube like this. So if this is the charge capital Q, so the flux is coming out like this. Is it clear? From the cube, from this face also the flux is coming like this, from this face also the flux is coming like this. So what is the total flux linked with this surface, linked with this cube? The total flux is nothing but the charge enclosed. What is the charge enclosed by this cube? Say Q upon epsilon naught. So the total flux linked with this cube is nothing but Q upon epsilon naught. So this is the first part. The flux linked with the cube is nothing but Q upon epsilon naught. The second part, the flux linked with the one face of the cube. Listen one thing. This charge is placed symmetrically, right, with respect to the faces of the cube. So if you consider this is the flux linked with the one face of the cube. So in the same way, the same flux is linked with this cube, the phi dash. Is it clear or not? So in the same way, if you consider this is the face, the phi dash will be there. So how many faces are there? Say 6 faces are there, and therefore phi dash plus phi dash plus phi dash plus phi dash plus phi dash, that is the total flux may be divided as the 6 phi dash. Is it clear or not? So 6 phi dash is nothing but Q upon epsilon naught, or you can say that the phi dash is nothing but the flux linked with one face is equal to Q upon 6 epsilon naught. So what is the flux link with one face? We are not calculating, we are not integrating anything. Only with the Gauss's law we are able to find the flux link with the one face is Q upon 6 epsilon naught, and the total flux link with this cube is Q upon epsilon naught, right? Copy this. So this question may be asked in this way. For example, they will give a face, right, like this. This is the face, this is the square of the side A, and at the above of the square at distance a by 2, the charge Q is placed over there, right? They will not directly ask this type of the question in this way. In the different way they can ask. So you have to find the electric flux with linked with square as shown in figure, right? So how to find this electric flux, please tell. If this is the A, this is what? Say A by 2. The flux is like this, the flux is like this, the flux is like this. Is it clear? The flux is like this, the flux is like this. Is it clear or not, you tell? So this flux you have to calculate. The charge is placed at distance a by 2 above the center of the square. So how to find this flux? This is the phi dash. How to find? Listen one thing. To solve this question, right? Suppose this is your one square. The charge is placed at distance a by 2. This is the q. So what will you do? You will assume that this charge is enclosed by this cube. Are you getting or not? If this is the a by 2, we have only the one square. So you can make an imaginary cube like this. So now this is the surface, this is the charge cube which is enclosed by this cube, right? So if this is it is placed on the center of the cube, then what is the flux link with the one face? The flux link with one face is nothing but q upon 6 epsilon naught. Is it clear or not? So they will ask the question in this way. They will not give the cube, rather they will give a square. They will give the square of the side A, and from its center at distance a by 2 the charge q is placed. Now you have to find the electric flux, right? So by yourself you can consider an imaginary cube like this, right? Like this, right? And therefore you may write the flux link with one face is q upon 6 epsilon naught, right? Copy this. So the second example, now if charge is placed, charge capital Q is placed, right, on mid of one face, right, mid of one face. Suppose this is the cube, right? This is the small cube like this, and the charge Q is placed over here, right? So you have to find flux linked with one cube, linked with cube. Is it clear or not? So this is the question. You have to find the flux linked with this cube. Is it clear or not? Like this. If this is the charge cube placed on the center of the one face, so look, this is the cube, this is the cube like this. Are you getting? This is the cube. In this way you can think. Fine. Like this. The charge q is placed over here. So if charge q is placed over here like this, so the flux will be passing through this cube in this way, in this way, in this way. Is it clear or not? So this is the flux link with the cube. Is it clear or not, you tell? So this is supposed to be the phi dash, right? So if you want to find the flux link with this cube, the one cube you can place just above the charge q, right, symmetrically like this. So if this is the flux phi dash link with this cube, so the same flux will be the phi dash link with the cube above the charge. Is it clear or not? So, and if you consider the total closed volume or the closed surface, so the net outward flux is nothing but charge enclosed divided by epsilon naught. So what is the flux, what is the charge enclosed by this closed surface? In this case the charge q is not enclosed because it is open on the outside, but now this charge comes in this charge is enclosed by this closed surface. So what is the charge enclosed by this closed surface? Is q. And what is the total flux? You will write the phi dash plus phi dash plus. So therefore the total phi dash, and the phi dash is what? Say q upon epsilon naught. And what is the phi dash? Phi dash is the flux linked with the cube. So answer is q upon 2 epsilon naught, right? Copy this. Now this is the one question. The another question, if charge q is placed, if q is placed right, at one edge, at mid of one edge, at mid of one edge, right? How? Suppose this is the cube, all right, and this is the cube like this, right? And the charge is placed on one edge like this. Is it clear? On the mid of the one edge, this is the charge q. Then you have to find the flux, find flux linked with q, flux linked with q, right? This is the question. Now let's see how to solve this question, right? First copy the question. So let's see how to solve this question. This is the cube. Suppose this is the cube over here. I'm making the small cube, right? The flux linked with this cube is supposed to be the, right? Suppose the flux linked with this cube is nothing but the phi dash. At least we can write the, but the flux is phi dash. This cube, this charge q is not enclosed by anything, right? So what you have to do, you have to imagine 4 cube. In this case, you had imagined the one cube just above the charge. If this is the charge q, you have to imagine the 4 cube like this, right? This is the 2 cube side by side, fine. These are the 2 cubes side by side. This is the charge q, and the 2 cube just below this like this, fine, like this. So how many cubes are now? These are the 4 cube. Now this charge q is enclosed by all this volume or all this 4 cube surface, right? What is the charge enclosed? The charge enclosed is q. If you write the outward flux, the Gauss's law is outward flux is equal to charge enclosed divided by epsilon naught. So charge is q upon epsilon naught, right? And listen one thing, because this charge q is placed symmetrically, what the flux is linked with this cube, the same flux is linked with this cube, the same flux is linked with this cube, and the same flux is linked with this cube. You understand or not, you tell? So the total flux is what? Phi dash, phi dash, phi dash, phi dash. So it is equal to what? Say 4 phi dash q upon epsilon naught, implies that phi dash is nothing but q upon 4 epsilon naught, right? So with the help of the Gauss's law, if the charge q is placed over here, the flux passing through this cube is nothing but the q upon 4 pi epsilon naught. So the Gauss's law is very helpful for finding the flux enclosed if the charge is symmetric, right? Charge or the electric field is symmetric, you can say, right? Copy this. Listen one thing. Now if this charge is placed at the one corner instead of the mid of the edge, right? Example, if q is placed at one corner, right? At one corner, then if it is placed on one corner, suppose this is the cube, right? And the charge q is placed over here, then what is the flux linked with this cube? You tell. Listen, to find the flux linked with this cube, suppose this is the cube and the flux linked with this cube is assumed to be the phi dash, right? So what you have to do, you have to imagine another cubes, right? So that this is enclosed symmetrically by that cubes. For example, if this is the cube over here, this is the charge cube placed is over here, I'm making the small cubes, right? This is the cube and you have to find the flux link with this. So this is the charge q. So one cube you can place beside it like this, and the 2 cubes, right? These are the one cube, the one cube just below this like this as shown in this figure, and you can suppose the 4 cubes are behind this charge q, and 4 cubes you can consider the in front of this charge q. So if the flux is phi dash, the flux link with this phi dash, the flux link with this phi dash, and the flux link with this is phi dash. You understand or not? So the phi dash, phi dash, phi dash, and the 4 cube in front of this charge q also. So how then the charge q, if you consider only the 4 cube like this, then charge q is not enclosed because the q is in front of this 4 cube and the 4 cubes in behind this charge q. So to enclose this, you have to assume that the 4 cubes are also placed in front of this, right? So the outward flux, total outward flux is nothing but the charge enclosed divided by epsilon naught, right? So q upon epsilon naught. And what is the flux? The total flux, phi dash, phi dash, phi dash, 4 phi dash, the flux linked with this 4 cube, and the 4 phi dash, the flux linked with the cube placed in front of this charge q. So therefore 8 phi dash is equal to q upon epsilon naught, and you may write phi dash is q upon 8 epsilon naught, right? So therefore the flux linked with this 1 cube, if it is placed at one corner, what is the flux link? The flux link with this cube is nothing but q upon 8 epsilon naught. Is it clear or not, you tell? Right? Copy this. Now the very important question not given in your sheet. Suppose this is the cube, right? This is the cube, all right, and this is the charge q over there. Are you getting? So the charge q is placed at one corner. So what is the flux link with this cube? Just we have found the flux link with this cube is nothing but q upon 8 epsilon naught. The total flux link with this one cube is 8 upon epsilon naught, right? In this case, you will see this is the face, right? This is the face which touched this charge, or this charge touched this face. The another face is this. This is the another face. So this is the one more face which touched the charge. So and this is the face. So this face is also touching this charge, all right? But if you consider this is the face, this is the above face, top face, this top face does not touch this charge. Is it clear or not? In the same way, if you consider this is the one more face, this is the face which is also not touching this face, and this is the front face, right? This is the front face, it is touching the charge, but the backward face, right, that is also not touching this charge. So in this cube, if you consider the charge q, for this charge q there are 3 touching face, TOUC, touching face, right, and 3 are non-touching face, non-touching faces. You understand or not? If the charge q is placed at the corner of the cube, there will be the 3 touching faces which is touched by charge. There are 3 non-touching faces. Find the flux. Find the flux linked with touching and non-touching faces. Non-touching faces. This is the question, right? Copy this. So listen one thing. There are 3 touching and 3 non-touching faces. You understand? First, I will try to find the flux link with the touching face, right? Suppose this is the base. This is the base. I am talking about this face, right? This is the square base. This is the charge q. All right. If this is the charge q, you will see the flux passing through this face will be in this way. So all the electric field lines, right, all the electric field line, right, link with this face is in the plane. Is it clear or not? If you consider this the surface area vector, and the electric field is always at 90 degree. You understand or not? So since all the electric field lines are in the plane of the face, so what will be the flux link with this? Please tell. The flux link with this is 0. Not only with this, Rather, if you consider the front face, this is the front face and this is the charge q. So because of this charge q, the electric field line are in the plane of this surface. This is the electric field vector, suppose, and this is the surface area vector, so which is 90 degree. So this is also phase, the flux is what, 0 0, linked with this. In the same way, if you consider this is the face, right, so the side face, left side face, so the electric field is again in this plane. So the flux linked with that face is also equal to 0, because electric field is perpendicular to the area vector. So if you consider the for 3 touching face, the flux link with is 0. You understand this question or not, Yutal? Right. Now we consider the non-touching face. For example, this is the one face, right, like this. If you consider the charge q is placed over here, and this is the topmost face, so the flux is passing through this face in this way. You understand or not? So if I assume this is the phi double dash, and the another face which is also non-touching, this face and this face are symmetric with respect to the q. So if the phi double dash is the face flux linked with this surface, and therefore the flux linked with face will also be the phi double dash. Is it clear or not? Not only these two faces are symmetric with respect to q, rather the back behind, right, the backward face, right, the flux linked with that also will be equal to the phi double dash. Is it clear or not, Yutal, now? So if you consider the total flux linked with this cube, total flux is what? Phi double dash plus phi double dash plus phi double dash. And what is the total flux linked with this cube we have found? It is equal to 8 upon, q upon 8 epsilon naught. So therefore the phi double dash is q upon 24 epsilon naught. So this is the phi double dash is the flux linked with one non-touching face. Is it clear or not? Q upon 24 epsilon naught is the flux linked with one non-touching face. With one non-touching face is q upon 24 epsilon naught. Is it clear or not? That is the answer. I think you understand. If you don't understand, I can explain this once again, right? Copy this. For example, one more question you should tell. If this is the hemispherical shell, this is hemispherical shell, right, hemispherical shell, right, and the charge q is placed over here. You have to find flux linked with this hemispherical shell, right? So how to find this, Yutal? If this is the hemispherical shell like this, if this is the charge q, the flux linked with this face is suppose the phi dash, but this is not the open face. The charge q is not placed, is not enclosed by this face. So to enclose this face, you must consider one more hemispherical shell just below this. Now this become a closed surface. Is it clear or not? So what is the charge enclosed by this surface? The capital Q is totally enclosed, and you will apply that Gauss's law. Total flux is the charge enclosed divided by epsilon naught and Q upon epsilon naught. So this is the phi dash is the flux, right, and this is also the phi dash. So phi dash plus phi dash, 2 phi dash upon Q epsilon naught. So phi dash is equal to Q upon 2 epsilon naught. So the flux linked with this one hemispherical surface is what? Q upon 2 epsilon naught. Is it clear? Listen, one more question. For example, if this is the cylinder, right, this is the cylinder, and the charge q is placed over here. So what is the flux linked with this cylinder? Same thing we will apply. We will consider the one more cylinder, imaginary cylinder. Now if you consider it become the complete cylinder, and this charge q is enclosed by this cylinder. So what is the charge enclosed by this Gaussian surface? Say capital Q, And if you consider this is the charge, right, this is the charge and the flux linked with this phi dash. So the same flux is linked with the below cylinder phi dash. So charge enclosed. So now the apply the Gauss's law, total flux is equal to charge enclosed divided by epsilon naught, q upon epsilon naught. Total flux is nothing but phi dash plus phi dash, q upon epsilon naught. So phi dash is what? Q upon 2 epsilon naught. So it means if it was the cylinder, this is the charge q, right? What is the flux? Phi dash. The phi dash linked with this cylinder is nothing but q upon 2 epsilon naught. Similarly to, right, the hemispherical shell, right? Copy this. So let's do one more question. If this is the cone, suppose this is the cone, the height of the cone is assumed to be the 4r and the radius is r and the charge q is placed over there, right, and the radius is to be r. Can you find the flux linked with this? Find flux linked with cone. Yes, any one of you can give the answer, right? Q, yes. The simple thing is that you will assume this is the one cone. So the phi dash from the above cone, phi dash is the one above cone. So the flux linked with this, right? You can assume I'm making the figure, right? Now the Q is enclosed, the charge enclosed is Q, and if this is the phi dash, right? The phi dash is linked with this the below cone. So the 2 phi dash is nothing but the charge enclosed divided by epsilon, the phi dash q upon 2 epsilon. But this is not the question, right? This is a simple thing. Here you have to consider this is the cone, right? This is the height of the cone. The charge q is placed over this. The charge q is placed at distance r and the radius is assumed to be the r, all right, and the height is assumed to be the 4r. Is it clear or not? You tell. So now can you yes, in this question, this is the question, find the flux linked with right lateral surface, yeah, conical surface, sorry, with conical surface of cone. What is the question? The question is that if this is the cone, right, and the u place the charge q, so the with the help of this charge q, right, the flux will be linked with the conical part. This is the conical part, right? You understand or not? The conical part, not from this base, right? Copy this. So how to solve this question? Please tell. I am writing the solution this side. Listen one thing. If you consider the total cone, now the charge q is enclosed by this cone. So what is the charge enclosed? Here q. So the net total flux is nothing but q upon epsilon naught. So the q upon epsilon naught is the total flux. Listen one more thing. What is the total flux? What do you mean by the total flux? Listen one thing. If you consider this is the disk of the radius r and this is the charge q. So can you write the electric flux link with this disk? Tell me. Can you write the electric flux link with this disk? Yes. At least we know the formula. What is the formula? The flux is nothing but q upon, sorry, the flux linked with the disk is not q upon 2 epsilon naught, 1 minus cos theta, if you remember, right? And this is the theta. Is it clear or not? You tell. This is the theta. If this is the r, this is r, what is the tan theta? The tan theta is r upon r is equal to 1. The theta is the 45 degree. So the q upon 2 epsilon naught 1 minus cos 45. And what is the value of the cos 45? This is q upon 2 epsilon naught 1 minus 1 by root 2 is the flux link with this face, link with this disk, right? So I'm assuming this is the phi dash. This is the flux link with the disk. And if you consider the complete cone, this is the cone. So the phi dash is linked with this disk and the remaining flux, you may assume this is to be the phi double dash. So this phi double dash we have to find. So the total flux is nothing but phi double dash plus phi dash. You understand or not? And total flux is nothing but charge enclosed divided by epsilon naught according to the Gauss's law. So what is the phi double dash? Phi dash is the flux linked with this disk using the formula we have found. So what is the phi double dash now? The phi double dash is the flux linked with the conical part of the cone is equal to total flux minus flux linked with the disk. So therefore Q upon epsilon naught, right, minus the phi dash is Q upon 2 epsilon naught 1 minus root 2. So if you take the Q upon epsilon naught common, 1 minus 1 by 2, 1 minus root 2, right? If we simplify, Q upon epsilon naught is equal to 1 minus 1 by 2 plus 1 upon 2 root 2, right? Q upon epsilon naught 1 by 2 plus 2 root 2, Q upon 2 epsilon naught and root 2 plus 1 upon, right, you may write it is 2 root 2, right? 2 root 2 epsilon naught root 2 plus 1 is the flux linked with this conical part, right? Copy this. I think you should understand. So let's do one more question. Suppose this is the sphere, right? This is the sphere of radius r over here and a line charge. This is the sphere, right? Sphere of radius r. The line charge is infinite, line charge is passing through in this way, right? And this linear charge density is lambda, coulomb per meter, link with this, right, like this, such that its angle made by this angle is 37 degree. Is it clear or not? So now you have to find flux linked with sphere, right, as shown in figure, right? This is the question, right? Copy this. So how to find the flux linked with this surface? Very simple. According to Gauss's law, we can apply the Gauss's law. What is the Gauss's law, you tell? Gauss's law is nothing but the net flux linked with the closed surface is nothing but charge enclosed divided by epsilon naught. So what is the charge enclosed by this Gaussian surface? This is the spherical shell. This is the charge enclosed you have to find. If the lambda coulomb per meter, if you are able to find the length of this wire, linear charge density lambda, right? If you are able to find this L, then you can find, right? Listen one thing. If this is the R, this angle is 37. This is also the 37. If you assume this is to be the X, so sine 37 is what? Is equal to perpendicular upon hypotenuse. 3 upon 5 is equal to X upon R. So X is equal to what? 3 upon 5R. So therefore this is also the X. Fine. So what is the length L? Is equal to 2X is equal to 6 upon 5R. This is the length L. So lambda coulomb per meter mean in 1 meter the charge is lambda coulomb. So in L 6 upon 5R meter, the charge is 6 upon 5 into R, and therefore the enclosed charge is 6 upon 5 lambda into R. Is it clear? So what is the outward flux linked with this, or the net flux linked with this surface is 6 upon 5 lambda R. The answer will be the total flux is 6 lambda R upon 5 epsilon naught, right? So this is the total flux linked with this closed surface. Is it clear or not? Right, copy this. So read this question. In this question, a sphere of radius R and the charge Q. If this is the radius R and the charge is what? Assumed to be Q, right? And it is placed in an imaginary sphere of radius 2R. Is it clear or not? So what is the flux linked with this imaginary sphere? The flux linked with this imaginary sphere is nothing but the charge enclosed divided by epsilon naught. So what is the charge enclosed by this sphere, imaginary sphere of radius 2r. What is the charge? Say only q, right? So the q upon epsilon naught. So the total flux linked with this imaginary sphere is q upon epsilon naught. Even if the radius of the sphere is 3r or 4r, the charge enclosed by the each sphere is q and the flux link will be the same, right? Obviously it must be the same. Why? Because this is the flux. The same flux is linked with the sphere of every radius more than r, right? Copy this. So which option is the correct option? A option is the correct option. So read this question. I have explained this question. The length of each side of cubical closed surface is L, right? And this is the shaded portion. And the charge Q is placed over the corner. You have to find the flux link with this. So this is the non-touching surface or not? What will be the flux link with this face? You tell. The flux is nothing but Q upon 24 epsilon naught, if you remember. I had explained, right? Tell me. So which option is okay? The option is not given. Q upon 24 epsilon naught is the total flux linked with this non-touching face, because if you remember, remember or not? Just I explain. This is the phi dash, this is the phi dash, and the 3 phi dash. 3 phi dash is nothing but Q upon 8 epsilon naught, right? The flux linked with this cube is Q upon 8 epsilon naught, and it is Q upon 24 epsilon naught. The flux linked with this one face only, right? Copy this. So read this question. An electric charge Q is placed at the center of the cube. Center of the cube of side alpha. The side is alpha, alpha, alpha. This is the capital Q charge. So you have to find the electric flux linked with the one face. Tell me, what is the electric flux linked with one face? The one phase flux is nothing but Q upon 6 epsilon naught. I had explained this, right? So Q upon 6 epsilon naught, the Q is small q over here. So the option A is again the correct option. Is it clear or not? Because the total flux linked with the surface is Q upon epsilon naught, and the total flux is nothing but the flux linked with the 6 symmetric faces, right? This is the phi dash, this is the phi dash, this is the phi dash, this is the phi dash. 6 phi dash is Q upon epsilon naught, right? And therefore the phi dash is nothing but Q upon 6 epsilon naught. The A option is the correct option, right? Copy this. So read this question. In this question, figure shows an imaginary cube of length L by 2. This is the cube of length L by 2. Is it clear? And a uniformly charged rod L moving towards left with a constant speed. Suppose this is the length of this rod is what? Say capital L. Is it clear or not, you tell? Right. At t is equal to 0, here is only the left and it is. Right. The face of the cube opposite to the which of the graph following the represent the flux. Listen one thing. Flux through the cube as shown as rod goes in this. Right. Listen one thing. When the rod is moving towards the left, what is happening, you tell? After some time, right, the some portion of the rod will be entered. Is it clear or not, you tell? Right. And some portion will be the out of the box. Right. After some time, what will happen? After some time, the this much, right? This is the like this. So the L by 2, the rod length is L by 2. So after some time, it is completely entered. You understand or not? When it will continue to move, what will happen? After some time, then what will happen? This will be the situation, right? This will be the situation. When it is going to move towards left, after some time, it will be the situation. Is it clear or not, you tell? And then after some time, the situation will be like this, right? The rod will be coming out from the cube, all right? And finally, the complete rod is over there, come out from the come out from this cube. So what is the flux? The flux linked with this cube. This is the cube, right? This is what cube? It is entering over here. So what is the charge enclosed over here? Say 0. And when the rod is completely come out from the cube, the enclosed charge is 0. So we will apply the Gauss's law. The net outward flux is equal to charge enclosed divided by epsilon naught. So you have to make the graph between the flux as a function of time t. Is it clear or not? Right. So from here to here, the time you can write, if the speed is u, it is moving with the speed u. So this point start from this and it move to this point, right? From here to here, what is the distance? If it is L, and this is what? Say L by 2. So the distance traveled by this point, the total time in this process, when this point, the end A, this is the end A and this is the end B. So the end A reaches to this point and the B reaches to this point. So how much distance is covered? Say L plus L by 2. So the total time is S is equal to ut. The total time is distance upon speed, the 3L by 2. The distance is L plus L by 2. The total distance is 3L by 2 upon speed is suppose u. So 3L upon 2u. This is the time. Is it clear or not? So tell me, when it is entering, some part of the rod is right entering over here. So what is this in time t? In time t, what is the x? X is equal to u into t. Is it clear or not? So what the time it will take to enter the complete rod in the cube, into the cube? So from here to here, this situation happen as S is equal to ut. I'm writing S is equal to ut. So t1 is equal to distance upon the speed. The distance is traveled by this rod is L by 2 and the speed is u. So L upon 2u is the total time taken, right? So the total time is taken is 2u by 2, L upon 2u. So the charge is increasing initially up to L upon 2u, right? And what is the x? X is the v into t, right? So what is the flux, outward flux? How would you write the outward flux for this case? The outward flux is nothing but charge enclosed divided by epsilon naught. And what is the charge enclosed? You will say lambda into x. If the linear charge density is lambda, so what is the charge enclosed in this portion? You will say lambda into x into epsilon naught. And what is the x? The x is nothing but ut. So the outward flux linked with this cube is proportional to t. So as the rod is entering, the charge is increasing enclosed by this cube and this flux, and therefore the charge is increasing, the flux is increasing. Flux is proportional to time. So if you draw the graph between the flux and the time, the graph is like this. Is it clear or not? Up to what time? From t is equal to 0, right, to t is equal to L upon, right, t1 is equal to L upon 2u. The flux will increase, right, because the charge now up to this point, the charge is what? Although the rod is moving towards, continuously moving towards left, but the charge enclosed by this cube here, if it is, this is the some charge enclosed, the maximum charge enclosed will be there, right? So the flux will be what? The maximum. The charge will be maximum and it will be same till this point, right? And this happen at time t2 is equal to L upon u, right? One more L upon u time it will take to reach this position. Therefore the flux here, the charge is constant, right? Therefore the flux will be constant till T2 is equal to L upon 2u, or you can write T2 is equal to 2L upon 2u, right? If further it is continuously moving, the charge enclosed by the cube is decreasing continuously, and finally the charge enclosed becomes 0. So therefore the flux will also be 0, and this is 3L upon, it happens on the time 3L upon U. So this is the graph between the flux and the time. Is it clear? What will be the maximum charge enclosed by this? Listen one thing. If the linear charge density is lambda, so what is the charge? If you want to find the charge enclosed, the distance is L by 2. The maximum charge enclosed is nothing but lambda into L by 2. Is it clear or not? If this is the maximum charge enclosed is lambda into L by 2, here is also the maximum charge L by 2. This is also the same charge, right? Up to L upon U, the charge enclosed is maximum by the cube, and it is lambda L upon 2. And what will be the maximum flux in this case? The maximum flux will be the charge enclosed maximum divided with epsilon naught. The maximum charge enclosed is lambda L by 2 upon epsilon naught, right? So lambda L upon 2 epsilon naught is the maximum flux, lambda L upon 2 epsilon naught, right? Although these things are not shown in the figure, but they may ask in the question in this way also, right? Copy this. So read this question, right? A charge Q is placed at the center of the open end of the cylindrical vessel. This is the cylindrical vessel like this, right? Although it is shown like this is the open mean, only the lateral surface and this is the cross section is over there. This is the Q, right? It is a small Q. So you have to find the flux linked with the surface of the vessel, mean you have to find this flux, right? I think we have done this question. To find the flux phi dash, you have to just imagine the cylinder, one more half cylinder in the upper surface. Now you will see that the flux is what? Say phi dash over there. Is it clear or not? And the total flux is nothing but charge enclosed divided by epsilon naught. The charge enclosed is now the small q, right, upon epsilon naught. The total flux is what? Total flux is the 2 phi dash is equal to q upon epsilon naught. The phi dash is q upon 2 epsilon naught. So the flux link with the surface is q upon 2 epsilon naught, right? Copy this. So read this question. For a given surface of the the Gauss's law state as this is the Gaussian surface, closed Gaussian surface. This is the circulation E dot ds, right? This is the integration, right? And this circle, or in some book it is written as like this, right? No difference between this. So if this is equal to 0, what does it mean, you tell? What does it mean? Listen one thing. If the E dot ds is equal to 0, it means the net outward flux is equal to what? Say 0. It is definitely. But it does not mean that the electric field on the surfaces must be 0. Why? Suppose the flux is going in this way, like this, right? So the electric field on this point at the surface does not mean the electric field is 0. Electric field may be over there on the surface of this closed surface. But if E dot ds integration is 0, it means the net outward flux is 0, or therefore the charge enclosed divided by epsilon naught. So the enclosed charge by this Gaussian surface must be 0. This is the thing. So what is the first option? The option A is the E is necessarily 0 on the E surface. No, it is not necessary. E may be there, right? But net flux is 0. The B point. E is perpendicular to the surface at every point. No, it is also not necessary. Although E dot ds will be 0, mean if the electric field and ds vector is 90 degree, at 90 degree, then it must be 0. But it is not necessary that electric field is always perpendicular. The electric field may be like this, right? Sorry, electric field may be like this. It is not perpendicular, right? It is not perpendicular. Electric field may be like this, not perpendicular. So it is not necessary to be electric field must be perpendicular. The C option. The total flux through the closed surface is 0, right? This is definitely correct, right? And the D point is what? The flux is only going out of the surface. No, the net flux is 0 when there is no meaning of the net flux to be going out from the closed surface, right? So the option C is the correct option, right? Copy this. So read this question. In this question, consider the charge configuration. This is the charge configuration. Spherical Gaussian surface. This is the plus Q1. This is minus Q1. And this is the Q2. Right. When calculating the electric flux overall, when you are calculating the electric flux, E dot ds is equal to charge enclosed divided by E naught. Right. This is the net outward flux. So they are asking at any point on the surface, right, the electric field will be due to what? You tell. I told you this is the very important point. Although this is the the charge enclosed over here, the electric field at this point E1, E2, at any point, the electric field will be due to all the charges, whatever the charge is present over here, right? It may be the Q1 or Q3, whatever the you assume the charge, but the electric field will be due to all the charges. Whether this charge Qt is coming or not, the electric field in this expression is due to the summation of the, right, it is the net electric field due to the electric field Q1, Q2, Q3, like that, right? So which option is the correct option? So the D option is the correct option, right? Copy this. So read this question. In this question, a cylinder of radius R and length L is placed like this in uniform electric field parallel to the cylinder axis, right? This is the electric field which is entering, and now this is the electric field like this coming out from the the cylinder. The total flux of for the surface of the cylinder is given by, tell me, what is the total flux for any closed surface placed in the uniform electric field, whether it is cylinder, whether it is any closed surface, whether it is sphere. What the flux is entering, the same flux is coming out from the closed volume. So the net outward flux is what? 0. Net outward flux is 0. Is it clear or not? Therefore, the charge enclosed divided by epsilon naught, the charge enclosed is also 0. So the D option is the correct option, right? Copy this. One more interesting question I am telling you, it will definitely appear in somewhere in your sheet. Suppose this is the disk of the radius R, right? And the electric field is what? Like this. This is the electric field. Fine. This is the electric field like this. Can you tell me what is the flux linked with this? You will say pi r square. Right. If this is the disk, this is the hemispherical shell. This is the disk. The electric field flux is E upon pi r square. The same electric field at the hemispherical shell, it is the radius, suppose. Is it clear or not? So the same flux will be there. So what is the flux? What will you say about the flux? The entering flux. The flux will be again, right, the phi is equal to E into pi r square. It is not the closed surface, first of all. It is the hemispherical shell. Hemispherical shell. Is it clear or not? So the flux entering over here, whether it is disk or whether it is what? Hemispherical shell. Even, listen one thing, if this is the circular portion and the instead of this hemisphere, there is a random, right, it is the irregular shape. When, is it clear or not? Like this, you may assume. If the radius is r, its radius is assumed to be r. So when the electric field is entering, so the same electric flux will be coming out from here or not, you tell. So whether it is disk, either hemispherical or any irregular shape. So the meaning is that, right, if you found the shadow of this portion, the shadow, that is the its projection area, right? Are you you can speak it as the shadow or projection area. The projection area in every case is pi r square. The projection area is nothing but pi r square. So the projection area multiplied by the electric field, the flux here will also be equal to E into pi r square. Whether it is only the disk or the hemisphere or any type, if this is the radius and this is the like this, right? So the flux linked with this surface will be again what the pi r square into E. Is it clear or not, you tell? Right? This is the thing. Copy this.